Hi, in this video we're going to look at the first of the new topics that you're going to cover in this year's differentiation course, and it's called the product rule. Now we're going to start out by looking at a simple function f of x is x plus 3, x plus 4. If I expand that out, I'm going to get x squared plus 7x plus 12. And if I go and find the derivative of this, I'm going to get 2x plus 7. That's simple enough, straightforward enough. Now, I'm going to put in over here a question: what do you observe? We need to look back at the function we started out with, and we need to look at the derivative that we've got. I want you to think about that. So I'm going to take another example and have a look at that. Well, if we go and find g of x, if I go and expand that, this is going to be x squared minus 6x plus 8. I go and find the derivative of this, and it's going to be 2x minus 6. So there's my initial function. Here is my derivative. Is there some link between the two? Go back to the first one, and then to the second one. You take a third example. H of x is x minus 3, x plus 2. Expand that, and I'm going to get this. Find the derivative of that, and I'm going to get 2x minus 1. Again, we look at this, and we look at that. Do we find a connection that exists there? Now, hopefully by now you will have seen that there is possibly a connection that we can draw on. And the connection is possibly this. I've got 2x over here, and I've got an x there and an x there. Does that give me my 2x? I think so. I go and choose a different color, and this is make the point slightly smaller. I've got a minus 3 over here, and I've got a plus 2 over here. Now minus 3 plus 2 gives me minus 1. So it looks like I could get to my derivative simply by looking at the elements inside the bracket. Does that hold in the previous one? I've got x and x. That gives me 2x. Yes. Minus 4 minus 2, that gives me minus 6. That holds. X and x gives me my 2x, plus 3 plus 4 gives me plus 7. That holds. So it looks like we've got a pattern that's emerging here. Let's take a look at this one. Well, when I expand this out, what am I going to get? I'm going to get 2x squared. That'll give me 8x, and 3x is going to give me plus 11x plus 12. And if I go and find the derivative of this, I'm going to come up with 4x plus 11. Now, this doesn't look that good, because what I've got now, 4x, I've got an x and a 2x and an x, that doesn't seem to work. I've got a 4 and a 3, which gives me 7, doesn't give me 11. Does this rule still hold? The rule that I had up top here, does it hold? If it only holds for certain situations, there's not much of a rule. Does it hold in this situation over here? Have a little think about that. Now, we can actually rewrite this. We could rewrite this as being 2x plus 3, because that's what my first bracket is. Now, if I'm going to make 4x, I'm going to have to double my x's, because that'll give me 2x, and 2x and 2x will give me 4x. If I want to make 11, I need to add 8 onto 3. And 8, quite fortunately, is 2 lots of 4. And so it seems like I could, in this situation, get to the point that I'm at before. But where does this 2 come from all of a sudden now? And, sorry about that, that's a question that we've got to ask. We've got to think about where does that come from? Because In fact, we've been hiding something all the way along in these examples that we've worked through over here. Yes, I could say x minus 3 plus x plus 2 gives me my 2x minus 1. But in fact, I multiplied this bracket over here by 1, and I multiplied this bracket over here by 1. Why by 1? Well, it's because the derivative of x is 1, and the derivative of x is 1. Why did I multiply this second bracket over here by 2? Well, because the derivative of 2x over here is 2. And this now brings us into our formula that we can use. I'm going to skip that example. I'm going to come back to it. This is what the product rule says. If you've got a product, two things being multiplied together, then the derivative of that product you're going to get by leaving one of the factors as it is and deriving the second factor, multiplying the two together, and then taking the factor that you didn't derive the previous example, the previous time, now deriving that and leaving the second factor by itself. And this is what we call the product rule, and we use it whenever we're finding the differential of a product. Now, in these first examples that we've gone through over here, it is fairly easy to go and multiply those things out, so I wouldn't bother about having to use a product rule here. But sometimes those multiplications can go a little bit harder. Let's have a look and see if it holds on this one. So here I could call this thing u and I could call that v. So now, using my formula down below over there, I can say dy dx is going to be u times dv dx plus v times du dx. So I'm going to keep u as it is. It's going to be x squared minus 2. And I'm going to find the derivative of v, which is simply going to be 1. Then I'm going to keep v as it is, x plus 3. And I'm going to find the derivative of u. And the derivative of u is going to be 2x. And now when I multiply all of that out, what am I going to end up with? I'm going to get x squared minus 2 plus 2x squared plus 6x. And I tidy that up, and I end up with 3x squared plus 6x minus 2. Would we have got that if we had expanded the expression over here? Well, if I multiply this out, what am I going to come up with? I'm going to come up with x cubed plus 3x squared minus 2x minus 6. And if I go and find the derivative of that now, that's going to give me 3x squared plus 6x minus 2. That statement and that statement correspond. And so we have got the right derivative using this formula. So let's take a harder example. Here we've got mx is equal to 2x cubed, 2x plus 3 all cubed times 4x squared minus 3x to the power 4. I think you can appreciate that multiplying out those things is going to be time consuming in the extreme. So let's figure out what is du dx. We're going to have to use the chain rule here. So I'm going to have my 2x plus 3 reduced down, and then I'm going to take the derivative of what's inside, and what's inside is just 2. So that's going to leave me with 6, 2x plus 3 to the power 3. If I look at the derivative of dv dx, In a similar sort of way, I'm going to get 4. No, it must be 4 times 4x squared minus 3x. It's going to be raised to the power 3. And the derivative of what's inside the bracket is going to be 8x minus 3. And so, if I want to try and find the derivative of this, so m dash of x, it's going to be u. So it's going to be 2x plus 3 raised to the power 3 multiplied by dv dx, which is going to be this monstrous thing over here, 4x squared minus 3x to the power 3 times 8x minus 3. And to it, I must add v, which is 4x squared minus 3x, all to the power 4, times by du dx, which is this thing over here, 6 times 2x plus 3 to the power 3. Now, I'm not going to go and multiply that out in any way further. I'm not going to try and expand those. But what I can see when I look through it is I do have a common factor of 2, and I do have a common factor of that over there shouldn't be 3, that should be 2. I do have a common factor of 2x squared, 2x plus 3 all squared, and I do have a common factor of 4x squared minus 3x to the power 3. So I can take all of that out. What am I left with now? Well, I've got 2 times 2x plus 3 times 8x minus 3 plus 3 times 4x squared minus 3x. And there we have our derived function. And that is quite a meaty expression. That's all for this one. Go and practice them now.